A uniform meter rule is balanced by a 4 Newton force. Here is a 4 Newton force which is acting in downward direction. Okay. What is the weight W of the meter rule? Like we are uh, here is W. Okay. Now let's calculate the distance. The distance from here till here, like the 0 is here. You can see 0 is here. From 0 till 50, there is the till pivot there is a 10, and from 10 till 50 the distance is 40. The perpendicular distance of weight is 40, and look at the perpendicular distance here. The perpendicular distance is 10 and force is 4 Newton. So we can find we know that clockwise movement and anti-clockwise movements are equal for in case of a balanced beam. So clockwise movement is generated by the weight, like in this direction, and anti-clockwise movement is generated by this 4 Newton force. So we know that movement is force into perpendicular distance. Force is weight and perpendicular distance is 40. For anti-clockwise movement, force is 4 and distance is 10. So it is 40, which is weight times 40. So 40 is cancelled with 40. So 40, so weight is equal to 1 newtons. So our possible option is this one. Okay, now let's see the 27th one. Two blocks are placed. Here is one block and here is second block, which balances on the pivot, like pivot is here at center, at its center. The weight of the beam is negligible. The beam is of negligible weight. Which diagram shows the forces acting on the beam? Okay, now you know that the weight of this beam, suppose whatever, there would be some weight of the beam that would be acting in downward direction. At the same time, the pivot would be applying some normal force in upward direction like this. This would be the normal force provided by the pivot. And the weight of this beam, this block would be acting in this direction, and the weight of this block would be acting in this direction. So now we can match that the normal force is acting in upward direction and the weight of two forces is acting in downward direction. Okay, the second thing is actually the pivot is at the center, and center means the distance from here to here is same as here to here. So when distance is same, it means their weights are also same. So suppose one second. Okay, let me check whether, like, the size of this vector is the magnitude of this weight. If they have same magnitude, then the size of this vector should be same. So this is what I mean to say. So if their size are same and the normal force is acting in upward direction, that would be the correct option. So let's see the possible options. Okay, just look at the option A and A. In option A, okay, it's a normal force, that's fine. Look at the weight. If this weight is smaller than this one, it means there would be a clockwise movement in it, because anti-clockwise movement is small. So that's incorrect option. Look at the normal force acting on it. Here the weight is small, here is the weight is large. So again, we can expect a clockwise movement here. And look at these two options. Okay, so the difference is actually the weight is negligible. The normal force is somehow in magnitude. So we can expect a small normal force because its weight is actually of negligible size. So I think so the possible option should be this one, because weight is negligible. '28. The stability of a bus is tested by tilting it on a ramp. Okay, it's a ramp. And it's a bus. So you can see it's a bus. And this is a ramp. Normally the ramp is normal. In order to check the stability, we just lift it like this, so that if there is a U-turn or like a hilly area and the bus is going to take a turn, it would not topple. The stability of bus is tested by tilting it on a ramp. Okay, it's a ramp and they are testing. Okay, these are the expected position of center of mass or center of gravity. The diagram shows a bus that is just about to topple over. Okay, where is the center of mass of the bus? We know that the lower the center of mass, you know, that the engine and petrol and most of the things are connected with the base of the cars and any, like if there is any car or vehicle, it's most of the mass is connected with its base. The reason is so that the center of mass would be lower. Like the base area is same, but if the center of mass would be lower, then the probability for a vehicle to topple is reduced. So we are expecting that, and this is the position of center of mass of a bus. So expectedly, this is I think so 33 or 34 angle. That is the maximum angle which a bus can with which a bus can survive. If the angle is increased from 33 or 34, less than 40, maybe 35, the original number is I don't know. I think I missed the original number, but around 33 or 34. If the number is increased from this, the bus will topple. Okay, let's move to the next one. A flat lamina is freely suspended. This is a lamina. The weight of lamina is 2 Newton. Okay. The weight is 2 Newtons. And center of mass is at C. Okay, it means 2 Newton would be here. PC is 0.5 meter. PQ is 0.40 meter. QC, this is QC, which is 0.30 meter. So these values are mentioned here. So QC is this one, and PQ is this one, and PC is this one. So we have these three sides. The lamina is displaced to the position shown. Center of mass and weight would be acting like down. Okay, so the question is, the flat lamina is freely suspended from P. Okay, one second. If it would be freely suspended, then this would not be the position of lamina. Lamina would be little tilted in this direction. It would be little here because it's P. So for P, it would be somewhere here. Okay. Now this is our pivot point, and this is weight. Weight would be acting from here in downward direction. And this is the perpendicular distance. Pivot is somewhere here. And this would be, I think so, perpendicular distance would be this one. So perpendicular distance time weight, perpendicular distance times weight. So red one is perpendicular distance and this blue one is weight. So we can find out moment. So the moment would be perpendicular distance is QC 0.3 and the weight is 2 Newton. So it would be 0.60. Okay. So lamina is actually going in this direction. So in order to make it balance, we are in need of, so it is actually anti-clockwise movement. So in order to balance it, we need a clockwise movement, which should be 0.60 Newton. So I think so, if I'm not wrong, this would be the movement, clockwise movement. We are in need of clockwise movement. So let's move to question number 30. A piece of uniform cord is suspended freely from a horizontal pin. Here is a horizontal pin. At which of the points shown is its center of gravity? So it is a kind of repeated question, which is number 10 or 11. You can see. So we are already done with this question, in which we mark C as the center of gravity. Center of gravity. Yes. Okay. Let's move to the next one. Okay, number 31. In 31, forces are applied to a uniform beam pivoted at its center. Here is a pivot point, and 10 Newton force is acting here. 10 Newton force is acting in downward direction, and here 10 Newton force is acting in upward direction. Both the forces are same, and their distance is also same. So you can see in case of which beam is balanced, you can see this force is going to create a clockwise movement, and this force is also going to create a clockwise movement. So it's a kind of couple. So it wouldn't be a balanced one, but it would be a couple in which both the moments will support each other to make a rotation in it. So A is not a balanced condition like situation. Let's move to B. A is incorrect. Let's move to B. See, the distance is 0.4 meter and this one is 10 newtons. So, and we know that this 10 Newton force is going to have a anti-clockwise movement, and it would be 10 times 0.4, and it would be 4 Newton meters. Similarly, we have a clockwise movement which would be in this direction. 10 Newton is the force and 0.2 is the perpendicular distance. So it is 2 Newton meter is the distance. So you can see clockwise movement is less than anti-clockwise movement. So it is not going to be a balanced like situation. Okay, let's move to the third one. In case of 5 Newton force, 5 Newton force is going to have a clockwise movement, and 10 Newton force is also going to have a clockwise movement. Both the forces are going to generate clockwise movement, and both clockwise movement would get added and create a couple. So this is also not a condition to create a balance. Let's move to next. Okay, let's move to D1. Okay, so 5 Newton force is acting in downward direction. So possibly we have anti-clockwise movement in it, and there is a 10 Newton force which is possibly clockwise movement. So clockwise movement is okay, anti-clockwise movement is the red one. So 10 Newton force and 0.2 is the perpendicular distance. So it is 2 Newtons meter. And clockwise movement is 5 Newton is the perpendicular force, and 0.4 is, 5 Newton is the force and 0.4 meter is the perpendicular distance. So it would be 2 Newton meter. So you can see the clockwise movement and anti-clockwise movements are equal. Clockwise movement is 2 Newton meter and anti-clockwise movement is also 2 Newton meter. So both are equal. Clockwise movement is equal to anti-clockwise movement. When clockwise movement and anti-clockwise movements are equal, it would be a balanced situation. So D is the correct option. Okay. Number 32. In number 32, you can see the diagram shows a boy of weight 500 Newton. The weight of the boy is acting in downward direction C, which is 500 Newton. Sitting on a seesaw. He sits 2 meters. Like the distance from the pivot is, this distance is 2 meters, 0.2 meters. Okay, 2 meters is the distance and 500 Newton is the. So possibly you can say there is a clockwise movement like this. So clockwise movement is how much? 500 times 2 is 1000. And now let's see anti-clockwise movement. Anti-clockwise movement is like the force is here and the distance is 4. What is the force F? We need to find out the force F. Need to balance the seesaw. To balance the seesaw, this force will create a anti-clockwise movement. So there would be a clockwise, anti-clockwise movement like this. So let's see. Force time perpendicular distance is 4. So we know that when it would be a balanced like situation, clockwise movement and anti-clockwise movements are equal. So clockwise movement is 1000 and clockwise movement is 4. So force is 250 newtons. So yes, the option is this one.